Hi. Now in this video we are going to talk about a wallet which follows the principle of decentralization, where the power is not concentrated to a single authority but to multiple people. With the help of this wallet, we get security, we get trust, we get full flexibility and full control. Now what is the name of this wallet? This wallet is Multi-Signature wallet. With the help of Multi-Signature wallet, we can have multiple signature for a single transaction. And I will explain you all these things in this particular course where I'm going to create a multi-signature wallet from scratch in our Solidity programming language. So I hope you are excited for this video, and if you are excited, let me know in the comment section below. So let's start. Now before starting with the smart contract project, let us first of all understand what is a multi-signature wallet, right? So a multi-signature wallet is a type of cryptocurrency wallet that requires more than one person to authorize transaction. Now, what do I mean by that? So let's say you have these number of bitcoins. Let's say you have a huge amount of cryptocurrency fund. You want to transfer this fund to some other party, or let's say this is your company which is holding this huge amount of fund, and your company wants to transfer this huge amount of fund to some other address. Now, if you are going to give access of these funds to a single party, the chances are very high that this single party can manipulate all your funds, right? Because you are giving all the access of your fund to a single party, which I don't think so you want, right? Because if we talk about blockchain is all about decentralization, where the power should not be concentrated to a single person, to a single authority, right? So what you can do is you can give access of all these funds not only to a single party, but to multiple parties. Now, giving access of these funds to multiple party, and when I'm saying access, what do I mean by is that now these funds cannot be accessed by a single party. For these funds to be accessible, we need the private key of both the parties. Like in this case, I'm showing you two parties. Definitely there can be more than two parties as well. They can be 3, 4, 5, as much as you want, because this multi-signature wallet will give you the authority to have multiple authorities. And until or unless these multiple authorities will give permission, will give confirmation of accessing these funds, no one can access these funds. No one can send or transfer these funds. And this is what we are going to create in our Solidity project. So what we are going to do is we are going to have a sender and a receiver. This sender will send some ether. Let's say this sender wants to do some kind of transaction, wants to send some amount of ether to this receiver. Now, in order to do that, this sender cannot directly send ether directly to this receiver. Now, in order to transfer these funds, this sender need confirmation from owners. So what he will do is he will submit a transaction. This transaction will be submitted to these owners, and these owners will have authority to either approve or to disapprove this transaction. And once these owners will give confirmation to this particular transaction, then only this ether will be transferred from sender address to the receiver address. And this is what we are going to do in our multi-signature wallet smart contract. And this is the beauty of multi-signature wallet. You can use the similar kind of functionality in any of your smart contract. Like in this case, if you will see, I'm using this submit transaction. Like this transaction can only be submitted when these owners will give approval, right? So in the same way, you can use the similar kind of functionality in any of the functions that you want. So let's say if you are creating a crowdfunding smart contract, or let's say you are creating a lottery smart contract. So you can use the concept of multi-signature wallet in those smart contracts as well, so that your smart contract is not under the control of a single party, but your smart contract is under the control of various parties. Okay. So this will be a fun lecture where we are going to create our smart contract from scratch and also going to deploy this smart contract on Fire blockchain. So now let's start with our smart contract. First of all, what we are going to do is we are going to create an array of address, okay? And this array of address will actually consist of the owners. So these will be the people who will be actually controlling this smart contract, okay? So let me present okay. And then we will have one more variable by the name of number of confirmation. So number confirmations required. So this is something which will be useful in order to confirm how many people have actually voted for a particular transaction. Okay. and then we will have one more uh, data type, that is struct. And in this struct we are going to have the address of the person to whom we want to send some amount of ether, then a value. Okay, so the amount of value that we want to send to this particular address, and then whether this particular transaction is executed or not. So we will store this information in this executed variable. Okay, now we will have one nested mapping, and this nested mapping will be from uint to mapping from address to bool. So this is something which will actually have the state that whether our transaction is confirmed or not, okay, which you will see when we will start coding our smart contract. But for now, let me create this particular variable. And then we will have an array of transaction struct. So we have created this struct, right? So now what we are trying to do is we are trying to create an array of this transaction type, okay, where we are going to store all our transaction. So public transactions. So these will be the data types, or I will say variables, that we are going to use in order to code our multi-sig wallet smart contract. Now we will create one constructor, and inside this constructor we will pass the array of owners, means the people who are actually responsible for signing this particular smart contract, for signing the transaction. Okay, so memory owners, I will say, and then we will have the number of confirmation that we require. So num confirmations required. Okay, and then we will check two things. First of all, we will check whether the owners dot length is greater than 1. So we are actually making sure that the number of owners who are like owners of this particular smart contract should be greater than 1, because if they are greater than 0, then only one person will be enough, right, for this particular wallet, which we do not want. We want that there should be at least one person, means at least in the sense there should be at least two people actually, which will actually make sure whether a transaction will get confirmed or not. Okay, so this is just what I want to code. Definitely it up to you. If you think, okay, no, it should be greater than 0, then you can take greater than 0 as well. Okay, and then we will have owners required. Okay, or I can say that owners required must be greater than 1. And then we will have another required statement, and in this we will check whether the number of confirmation required is greater than 0 and number of confirmation required is less than equal to owners dot length. Okay, because if the number of owners are only 2, then we cannot wait for confirmation for 3 people, right? So we are making sure that, so owners dot length, otherwise you will throw an error that number of confirmation are not in sync with the number of owners. Okay, and then we will have our loop uint I equal to 0, I should be less than owners dot length I plus plus. And now what we will do is we will check whether the owner that are passed as an argument to this constructor, whether they are valid or not. If they are valid, then definitely we are going to push it in our owners array, this array, right? Otherwise we are going to throw an error. So first of all, let me check require whether the owners dot I dot, not actually dot, should not be equal to address 0, right? Means it should not contain any empty addresses. Otherwise we are going to throw an error, invalid owner. Okay, and then we will push this particular owner once this is confirmed, means this is a valid owner address, then we will push this particular address. So this will maintain the owners list that we are actually, that we want to create, okay, which we will require whenever we have to give confirmation for a particular transaction. And then we will make sure that the number of confirmation required is equal to the number of confirmation required that is passed as an argument. Okay, so this is done. So this is ready. Okay, now we will create other functions which will actually make sure that our transactions are actually happening. Okay, So let me create the first function by the name of submit transaction. So if someone wants to do any kind of transaction, they will call this particular submit transaction function, and this submit transaction function will then take those transaction input, and then it will do nothing. Okay, it will do nothing. Let me show you that. So it will take the address to, means the person to whom we want to do some, whom we want to send some amount of ether. So to, then we will have public, and it will be payable. Okay, and now inside this, first of all, we will check whether the to address that we are passing is not equal to, again, an empty address. Otherwise we will throw an error that invalid receiver address. Okay, something like this. And then we will check for the message dot value, means the ether that is sent to this, that the ether that is sent by the person, like who is calling this submit transaction uh, function. Okay, so the message dot value should be greater than 0. Otherwise we will throw an error that transfer amount must be greater than 0. Okay, and if these two conditions are good, means if these two conditions are met, in that way what we are going to do is we are going to create a transaction ID, and we are going to do a trick here. What we are trying to do, what we will do actually here is we will take the transactions array that we have created here, right? So this is the transactions array, right? And we will just find out its length. So initially, if you will see, transactions.length will be 0, right? Because initially there are no elements inside our array. So by default, it will be 0, right? Initially, the length of the array will be 0. And then once this transaction is done, means once we will have the transactions, what we will do is we will have the transactions dot push. Okay, so we are again using our array, and we are pushing this particular value, that is transaction, and inside this we will have the structured element. So this is the structure, right? We are pushing the structure, this structure. And then in this we will have to, means the address of the person to whom we want to send this amount of ether, and the value that we want to send is given in the message dot value global variable. And then we will have executed status, which will be false initially, right? And this is done. And in this way we are actually submitting our transaction. So just one thing to point out here is that we are just submitting the transactions, we are just recording the transactions, but actually the transaction is not taking place here. So let's say if someone is trying to, for example, let's say, let me go to this deployment tab. Let's say if 05B3 wants to send some 10 ether to this 0AB8 address, in that case, when he will call, when this 0B3 will call this submit transaction, in that case 10 ether will not be transferred to this particular address. It will be submitted to this particular smart contract, and it will be added to the transaction list, but it will not, this particular transaction will not actually happen. For this transaction to happen, what we are going to do is we are going to use our multi-signature wallet concept. But before that, let me do one more thing. Let me create some events as well. So let me create one event here, and let me name this event as transaction submitted. Okay, and inside this transaction submitted we will have the transaction ID. Okay, and the person who is actually doing this transaction, so address of the sender and the address of the receiver. And let's say I want to have the amount that they are trying to send, like the amount the sender has sent to the receiver, so amount. Okay, and what we can do is we can emit this particular event, right? So let me copy this down from here only, and let me emit it. So emit, and this, and in the transaction ID we will have this particular thing, right? Transaction ID only. So let me remove this data type from here. And in address dot sender, like not address dot sender, actually in address sender we will have message dot sender, the person who has actually called this particular function. And in the receiver part we will have the address of 2, right? And in the amount we will have message dot value. So this will be an event that will be emitted. This is definitely not compulsory, but I think it will be a good practice to have an event whenever our transaction is submitted. So it's up to you. Okay, let me close this down. Okay, any issue? Let me see what is the issue here. Okay, I think I missed these small brackets, right? I think now this is good. Yes. Good. So now this is our submit transaction. Okay, am I missing some parentheses? Where is this missing parenthesis, right? Okay, here it is. Okay, now let us create one more function, okay, by the name of confirm transaction. Now this will be something which will be confirming the transaction that is done in the previous step, in this submit transaction step. So in this we will have again the transaction ID. Let me make this public, and now again I will check first of all that the transaction ID that is actually sent should be less than the transaction dot length, right? Because whenever we are actually submitting a transaction, we are actually increasing the length of our array, right? So in the first case, let's say if someone is doing some transaction in the starting, then the array length will get increased by 1, right? When this push operation will take place, then the array length will get increased by 1. So the transaction ID should be always less than this transaction dot length, right? So we are making sure of that. Otherwise we are going to print that invalid transaction ID. Then we will have require. Now in this require, what we are going to do is we are going to use this particular data structure, or I will say this particular nested mapping is confirmed. Now this is confirmed will make sure whether a particular transaction ID is confirmed by a owner or not. So what we will do is we will have not is confirmed, and in the starting we will have the transaction ID, okay, and in this we will have the message.sender. So what we are actually making sure is that whether this particular address has given confirmation for this particular transaction ID or not. And if this is not true, then only we are going to pass this. Otherwise, we are going to throw an error that transaction is already confirmed by the owner. So means this is already confirmed, so no need to reconfirm it from this particular owner, right? And when these two conditions will pass, then we are going to make this transaction ID, okay, transaction ID message.sender equal to true, okay. So this is to give the confirmation, right? And I will show you how, like, if you're not getting this, what is actually happening, just don't worry. Once we will complete this smart contract, once we will test this smart contract, you will able to understand each and everything. So for now, what we are trying to do here is, if a person is calling this particular confirm transaction, that particular person is actually giving confirmation to this particular transaction ID, okay? And in our case, only the owner will do that. So you can have, if you want, you can have a modifier saying that, okay, only the owner can call this particular transaction or this function, but we do not require that. And you will understand why I'm saying this once we will go to the further functions, that is the execute transaction function and to do execute transaction function, okay. And then once this is done, once this confirmation is done, we can again create an event by the name of, let's say, event transaction confirmed. So this is for the confirmation. So once the confirmation is done, we are going to emit this particular event, and in this we will have the transaction ID, okay. And let us emit this. Let me copy this and let me emit this. Once the transaction is confirmed, then we will emit this. Let me remove this, and then this. We will create one more, we will actually call two functions here. Let me write it down for now. We are going to call two more functions here. Let me write pass for now, okay, so that we remember that we need to call two functions here. And what are those two functions? Let me create those two functions, and then I will explain like what are those functions that I'm talking about. So the first function that I'm going to create is transaction confirmed. So this is a function which will make sure, which will actually check whether a transaction is confirmed or not. In this, again, we will pass the transaction ID, public, view, returns, and this will actually return bold type, okay. First of all, we will check this particular thing. So let me copy this from here only, whether the transaction is a valid transaction or not. And then we will create one variable by the name of confirmation count. Okay. And it will be initially 0, right? Initially it will be 0. And now we will create one loop, unti I should be less than owners dot length I plus plus. Now this is something which will actually check whether a particular transaction is confirmed by an owner or not. So if is confirmed, so this is the data type, this is the nested mapping that we have created, right? The variable that we have created. In this we will pass the transaction ID, and then we will pass the owner's address by using our owner's array. Okay, so this is our owner's array, right, that we have created here. So this owner's array, and this will be passed, okay, to this nested mapping. And if this thing is true, means the confirmation is given by a particular owner to this particular transaction ID. In that case, what we will do is we will increase the confirmation count. We will increase the confirmation count. So as I said, right, during the confirmation only, I told you that whenever a particular address will give confirmation to a particular transaction ID, means whenever an owner will give confirmation to a particular transaction ID, which is, you can clearly see here, in that case, we are actually making this particular mapping true, right? So this message.sender means this particular person has given confirmation to this particular transaction ID. And if the same address is present here, means if this owner's list, means this owner's list will consist of all the addresses of the owner. So if this particular owner has given confirmation to this particular transaction ID, in that case it will be true, right? Because we are actually making it true in the confirmation transaction. So if this will be true, means the confirmation count will be increased by 1. And if this confirmation count is increased by 1, and when this confirmation count is less than or equal to, I will say not actually less than, greater than or equal to number of confirmation required, in that case it will return true, right? So it will return true, that okay, the confirmation count for this particular transaction ID is greater than the number of confirmation required. So let's say if the number of confirmation required is only 2 and the confirmation given by, let's say, 3 owners, in that case definitely this will be true and this transaction will be confirmed by all the owners, not actually by all the owners, but yes, the limited number of owners that we require. And I will show you again. If you are confused, just don't worry, once we will complete this you will understand each and everything. Okay, and this is what we are going to call in this particular function, that if is transaction confirmed, we are going to call this particular transaction ID from this particular function confirm transaction. And if this is true, right, if this particular thing returns true, means if this condition is true, then it will return true here. So if this is true, in that case what we are going to do is we are going to execute the transaction, execute transaction. So let me show you transaction ID. Now we need to create this execute transaction function, definitely. And this execute transaction function will be like this, execute transaction. In this we will have the transaction ID, we will make this public and we will make this payable. Okay, because this will be the function which will be actually transferring fund to the particular address. Okay, so after submitting of transaction, once this particular function will be executed, then only, and instead of making it public, what we can do is we can make it internal, because we are not going to require it in the public, right? And we can also make this particular function is transaction confirm public, not actually public, internal, because we are going to require only this particular function in the public and this particular function in the public, so that the owner can access this particular function, and if someone wants to send some transaction, then they can access this particular function. But these two functions need to be public, so let me make it internal only. Okay, now in execute transaction, again we will check for the same thing, paste it. Okay, there are some error, let me check these errors. What is the error? Okay, I think it should be underscore, right? And now in this, what is the error? Let me check. Okay, it should be like this. And what is the issue here? Okay, internal and private cannot be payable, so I cannot make it internal. So I need to make it again public or external, whatever I want. Okay, let's do this. So now let me save it. I hope there is no issue. Okay, it should not be external as well because I'm calling it within the contract, right? So let me make it public only. Yeah, now we are done. So now what we will do is, first of all, let me create one, or instead of, let's do not create anything. Let's directly do a require statement check, require, and transactions, transaction ID. Means what we are trying to do here is we are checking whether a particular transaction which is given in this transaction list is executed or not. So dot executed, this should be, means the transaction should not be executed, right? So it should require not of transaction executed, and otherwise we are going to throw an error that the transaction is already executed. And if this is true, then what we will do is we will make this true in the next line, means this particular transaction is now executed, and then we will execute this transaction, or instead of having it here we can have it afterwards. Let me for now comment it out. Okay, and instead of this, let me first of all execute this transaction. And to execute this transaction, again I'm going to use this transaction, right, which is actually given in this transaction list. So we are accessing this particular transaction of this particular transaction ID, right? So this is an array, right? And now we will go to the to part, means to the address of the recipient, means this particular address. Okay, we are actually having this address, right, here, this address of 2. So now we are actually sending ether to this particular address, dot to dot call. So we are actually making an internal call, and then we are simply going to pass the transaction. Let me again copy this, dot value, right? So this, we are accessing this particular variable of this transaction structure. Okay, and then we will have small brackets, and then we will have empty. Why? Because this is a syntax of Solidity. Okay, that when we want to transfer some ether to some particular address, so by this what we are trying to do is we are actually accessing this particular address which is actually given in this particular structure, and then we are transferring this particular value, this value. Okay, but let me tell you one thing here, that so that you are not confused, that this particular thing is actually the transaction data that we want to send. Now in this case we do not want to send any kind of transaction data, that's why I'm having this as empty. And then what we will do is this particular thing, this particular actually syntax will actually return us with the value, means whether the transaction is confirmed or not. And this value will be in this bool success variable. Okay, and if this is true, means if this thing is successful and the transaction is done, then this success variable will be true. And then if this is true, then we will say that okay, the transaction is done, otherwise we will throw an error. So require success, so it should be true, otherwise we will throw an error that transaction execution failed. Okay, and then what we can do is we can create an event as well here, event, and this will be the transaction executed event. This we will have the transaction ID, and again we will take this particular transaction executed, we will have this here, and then we will have the transaction ID. Okay, this is done. Let me emit this particular event. Okay, and let me copy this down. So once the transaction is successful, what we can do is we can have this particular thing. Okay, let me save it to check whether we do not have any syntax error. Okay, so everything is good. I know you might be a little bit confused at what is actually going on. I can totally understand. Just don't worry, I'm explaining you the whole smart contract, and then you will be able to understand each and everything. Okay, so now let me give you a summary of this smart contract so that you have no confusion regarding any of the functions that we have mentioned here. So first of all, we have actually declared some variables which were necessary in order to create our multi-signature wallet. Okay, then we created some events, right? And we emitted these events during the time of transaction submission, transaction confirmation, and transaction execution. Then in the constructor part, we are just initializing the owners addresses, means the owners of this multi-signature wallet who will be actually having an authority over this multi-signature wallet. And then we have the number of confirmation required. Okay, after this, we created a function by the name of submit transaction, and this submit transaction is only there so that we can register the transaction. We will not execute this transaction, we will just register the transaction by pushing the values in this transaction array, right, that we have created here, right? And after that, we created one more function by the name of confirm transaction. Now, this is the function which will be called by the owner of the multi-signature wallet, owners of the multi-signature wallet, so that they can confirm the submitted transaction. So in this case, let's say if someone is submitting a transaction, so initially the ID will be 0, okay? And let's say if someone wants to confirm that transaction, they need to pass the ID of that transaction. And once the confirmation is done from their end, and once we have the minimum number of confirmations, then we can execute this transaction. And we are doing this by calling the is transaction confirmed method, and by calling this execution transaction means execute transaction function. Okay, so once we are calling this confirm transaction, we are actually calling this is transaction confirmed. So this is actually making sure whether we have the confirmation count greater than the minimum number of confirmation required. And we are doing this by using this loop. And once this is done, once we have the result, we are actually either sending true or false. So if the number of confirmation means if the confirmation count is less than the number of confirmation required, in that case it will return false, and it will return false here. So this execute transaction function will never be called, right, because this will be false. So since this is false, it will never go inside this if loop. And if this is true, right, if this is true, then and then only this execute transaction function will be called. And once this execute transaction function is called, then this particular means any particular submitted transaction will get executed. So this is a very simple smart contract which is actually making sure that the transaction is evaluated, the transaction is executed only when we have the minimum number of confirmation from the owners of this multi-signature wallet. And you can use the similar kind of functionality, as I said, in any of the smart contract of your choice. You have to just use the same functionalities that we are using, and you can use the same concept in any of your smart contract project. And now it's time to test our smart contract. Now let us quickly test our smart contract whether it is working perfectly fine or not. So to test our smart contract, first of all, if you will see, we need to provide the address of the owner, right? Means the address of the owners actually, and the number of confirmation required. So in this, let me pass these two addresses, that is 05B3 and AB8. And let me do one thing. Let me open online note. Now this will be very helpful. You will understand why, that I can quickly copy paste the things. Okay, now inside this I will have this particular address, and I will have this in double quotes, and then again I will have one more address as owner. So let me take this address, copy, and let me paste this in double quotes, enter. So now let me copy these two addresses, and these two addresses will be the owner of our multi-signature wallet. Means after the confirmation from these two addresses only, a particular transaction will be confirmed. So let me have this, and the confirmation required, let me have 2, because we have 2 people, so I'm taking 2 only. Definitely if there were, let's say, 3 people, then I can take confirmation as less than 3, less than or equal to 3. But in our case, since we are only taking 2 addresses for confirmation, owner as like 2 addresses as owner for confirmation, that's why I'm having 2 here. Okay, now I will do transact. So this transaction is successful. Let us see our multi-signature wallet. Let us check our owners. So this is the first owner, and this is the second owner. Okay, now if you will see the number of confirmation, it is 2. That's great. And now let us do some transaction. So currently, if you will see, we do not have any kind of transaction, so it actually give us an error. Okay, the transaction has been reverted. So now let us do one thing. Let me go to this particular address, that is 04B2, and let's say this particular address wants to send 20 ether. So this 04B2 wants to send 20 ether to this 787 address. Okay, so I will copy this address, I will go back to 04B2, and then I will go to for this submit transaction. Okay, and I will paste the address. So now if you will see, 787 is the address to whom we are going to send 20 ether, but it will only submit the transaction. Means when this person will call this submit transaction, then 20 ether will be submitted as a transaction. Okay, let me do that. So I'm doing transact. So this transaction is successful, and you will see that 20 ether has been transferred to the contract address, because this is a payable function, right? And if you will see, 20 ether has been detected from 04B2, but still 20 ether has not been transferred to 787. Why? Because as I said, this is a multi-signature wallet. In order to confirm this transaction that we have submitted, like this particular address has submitted, these two address need to, like these two owners need to confirm this particular transaction, right? Until now the transaction is not confirmed, so that's why it is not executed. And we can check the transaction now. So this is the transaction at 0th index. This is the address to whom we want to send 20 ether. So this is given in way, that's why it's such a long value, and it is still not executed, right? That's why it is false. So now what we will do is, now we will execute this particular transaction by confirming the transaction. And for that, we need to go back to the owner's address, that is 0405B3, and 05B3, let's say, wants to give confirmation for this particular transaction ID, that is 0th. Okay, so it will do confirm transaction. So now this transaction confirmation is given. We can check in the transaction tab here. So first address, that is 05B3, has actually given confirmation for this particular transaction ID. But still, if you will see, 20 ether has not been transferred to the 787 address, because we need confirmation from two people, right? So we need to go to 0AB8, and then we need to again confirm this transaction. And as soon as I have clicked on this confirm transaction, you can clearly see that 20 ether has been detected from the smart contract address, and it has been transferred to 787. So now 787 has 120 ether. And this is how our multi-signature wallet works. That by having the address of owners, we can make this smart contract work only when the number of confirmation is greater than equal to the number of confirmation that we have passed, right? So this is it, right? And I hope this is a really helpful video for you, because you can use this kind of concept in any of the smart contract that you're trying to implement. I have implemented it for the transaction part, but definitely you can implement the same thing for any smart contract that you want to create, and for any smart contract where you do not want to give access to the power to a single authority but to multiple authorities, where democracy is there, that okay, if let's say these number of people are voting for a particular transaction, then only that particular transaction will happen, otherwise that transaction will not happen. In this case, as I said, we are using transaction, but definitely you can have any other function here, right? And you can use this concept of multi-signature wallet there. Now it's time to deploy this smart contract on Fire testnet. So let's see. Now in order to deploy our smart contract on the Fire blockchain, what we need is Fire test network. And to have Fire test network, what we need to do is we need to simply go to our browser and then paste this particular URL, that is https explorer.fire.network/dashboard. And I will provide the link in the description so that you can directly access it from there. And once you will enter it, you will see that it has a beautiful interface where you can see all the blocks that are actually being the part of the Fire blockchain. So here, the block hash, block number, timestamp, and all the details related to the Fire blockchain can be seen here. And if you will go to this faucet tab, okay, just go to this faucet tab, you will see an option for a native chain. But since we want to deploy this on the EVM compatible Fire blockchain, what we need to do is we need to switch this chain. So once we will switch this, it will give access to our EVM chain of Fire blockchain. And now what we will do is we will simply click on this add fire network. Now once you will click on add fire network, it will actually add fire test network into your MetaMask wallet, and then simply click on approve switch network. And once you will do this, you will see fire test network added to your MetaMask wallet. Okay. Now, once this Fire test network is added to your MetaMask wallet, what you need to do is you need to simply copy the account address, paste the account address here, and then enter up to 100 Fire coins. Okay. So here I will enter 100 and then I will click on send. Now, once I will do this, you will see that my account will be transferred with 100 Fire tokens. So here you can see that. Now we can use these 100 Fire tokens in order to deploy our smart contract on the Fire blockchain. Okay, so now it is time to deploy our smart contract on the Fire blockchain. And in order to deploy our smart contract on a Fire blockchain, what we need to do is we need to go to the environment tab. In this, we need to select injected provider MetaMask, and then we will type the password of our MetaMask wallet, and then we need to connect our MetaMask wallet to the Fire test network. And we have seen that, right? How we can add Fire test network in our MetaMask wallet. And now what we need to do is we need to simply click on this deploy button. As you can clearly see, our Remix ID is connected to the Fire test network. And to deploy this, we will simply click on transact. I'm providing the same addresses as before. Okay. And then I will click on confirm. Now let's wait for our transaction to get confirmed, and it is confirmed. It is fast. I think Fire blockchain is fast, right? And in order to test, like in order to check whether our smart contract has deployed on the Fire blockchain or not, we need to simply go to and copy the transaction hash. Let me see, where is the transaction hash? Copy the transaction ID. Okay, so we can copy the transaction ID. And then what we can do is we can go to Fire Explorer. Okay, I think this was it. Explorer.fire.network. I will provide the link in the description. And I will select EVM chain from here. And remember to select the EVM chain because you are actually deploying on the EVM compatible Fire blockchain. Just go to the transaction tab, paste your transaction ID, press enter, and hooray. So here is our transaction hash from the address that has deployed this contract. So you can clearly see this is the contract address 0x70, which you can also see here 0x70, and this is a successful status. So this is great, right? We have deployed our smart contract on the Fire blockchain in such a simple manner. Okay. So I hope you enjoyed this video and you have learned a lot from this video. And if you had, do let me know in the comment section below, and do like and subscribe to this channel because I'm regularly going to upload new blockchain courses on this channel. And if you have liked my this video, you will also like my this video where I have talked about Coffee decentralized application app, and this video where I have talked about NFT minting website. So do enjoy this video. Meet you soon in the next video.